We've made the point before that we must distinguish linear algebraic or matrix operations, like matrix multiplication and exponentiation, from element-wise operations, which are typically marked with a period on the operator. The major reason that an engineer would be interested in matrix equations at all is to solve them. We build them to describe systems of differential equations, and then we use a solver to produce the values for the unknown in that expression. MATLAB has been optimized to efficiently solve matrix problems. So we've called this the canonical equation of engineering. It's a matrix A times a vector of unknowns x equals a vector f. Typically we know A and we know f, and we'd like to find out what x yields f given A. Now the formal way of solving this equation is pretty straightforward. What you would do is you would multiply both sides times the matrix inverse, and this would simplify out to an identity matrix. A inverse times A gives identity matrix, and then we end up with x equals inverse of A times f. MATLAB can quickly calculate such a result. So here we've set up a matrix A, we've set up a row vector B, and then transposed it to be a column vector. And we're calculating the inverse of A times B, and in this case our values x come out to be 1 1/3, negative 1 2/3, positive 1 2/3. Now A looks like this. The inverse of A looks like this, so it's following simple rules. But in general, when solving differential equations, most of the values in A are zeros, and the values that aren't zeros tend to cluster around the main diagonal, or in this case the main diagonal would be the value 1, 2, and 6, and maybe you'd have other values next to that, but the farther away you get from it, the more likely it is that those values are zero. Since you frequently have a lot of zero values in this matrix, it turns out to be inefficient to do things like calculate the inverse. So we're going to see another way to solve this kind of problem. So for any matrix A and solution vector B, we can use what's called left division in MATLAB. So you notice we're using a backslash here. That's the key that's next to your return key on your keyboard. If we A backslash B, we are going to say A left divided by B. What this does is it takes A and B and finds an efficient way of solving this problem. So our problem for solving A via the inverse gets exacerbated as we get larger and larger matrices, as we solve bigger and bigger problems. It's not the most computationally efficient way to do it. It takes up too much memory. It takes up too much time to calculate. So there are faster techniques that have been developed over the last half century. So A left divided by B applies some set of those known solution methods.